they're and they're kissing at the mic. And they're like, all right, mic check. So all the mics should be completely stand up. So it was.
Administrative notes? Or are they? Oh, you probably are opening.
Administrative notes on slide like yours. Oh, everyone look forward to that.
Okay. So, what?
These people from a past class.
Yes, I was lazy to update. I will put there your photographs. No, I don't have your photographs, only from the campus connection, because camera is not working and it will not work for another month. So maybe we need to change the class, because they are so quick in helping people.
It's like the government. Go to the DMV, it takes 7 hours just to get a single like file.
Maybe we'll give them chance, but if they do not correct this by coming Friday, next Friday we'll meet in the same place where we meet for the labs. Yeah, but BBQ, QBB.
You know, I'm not gonna play.
So you. The wellness center nearby the pool, they have a wet class.
We're just gonna, like, I'm just gonna be like doing like water aerobics, and to me it's just gonna be like, okay, so away.
Sure, lab work appropriate for the class. So next Friday we'll have a midterm.
What now?
Midterm.
A midterm?
Yes.
Next.
On what?
You have right. No, we are not learning them. You learn them themselves and you teach me. I think it is very doable and you'll be happy with this. It's much easier than
It'll be very Googleable.
yeah, I'll provide materials and Google what he told.
Googleable. Hey,
Google.
I woke up like an hour. I skipped out of my first class.
He was not there. Dr. Webster made note of your absence. Yeah, he was like, some people decided to take a extra long weekend.
I just needed a rest. What class is that?
Coding's one.
So is it doable? Because it is Googleable.
Sure. Now
So-
that we have really a choice here, you're the
Give it
professor.
a solid try.
Okay.
Best efforts.
Okay. I will show the basically all postulates that you need to present can be reported in one text page. So the thing that I do not want you to do is just make a quote of a paragraph that relates to postulate and enjoy. I'm done. So we need to more like teach each other and interpret and maybe find something in addition. And do you we need to sign up list who selects which one. We can do it now or on Wednesday, because I think Monday we celebrate, or we can do right now.
Everybody's favorite.
Okay. So maybe before we leave we sign up, and it doesn't matter which one, but maybe someone likes to present first, someone wants to.
I'll take second.
I'll go third.
So Melody, who's second? Sam. And I looked into Campus Connection. So your name is written with AVA. You're telling me, but I didn't believe. I thought it is a joke. Okay. Elsa. Okay.
I have to go last.
Thanks for volunteering.
Fred.
Yep.
because you were telling that it doesn't matter. Mm, 6. What do we do? I probably need to represent number 6.
Oh, I don't either. I'm just looking at this blank sheet. That and it's on there.
Yeah, what is a
Like a room?
Wow.
6.
What?
Those are the.
Oh, I know exactly what you're talking about.
Maybe number 5.
Joke about it. No, there were other people got to, don't worry.
Well, if I do not want to present myself as a number 6,
That makes me feel better.
maybe we need to merge some postulates. Which one is shorter and simpler?
Whatever just give Melody to. She wanted to go first. She wants.
No. Number 1 is long enough. Number 2 is long enough.
No. I don't think one's long enough.
I like the friendly atmosphere in the class and your spirit of mutual support. I think the 3 is the shortest. Yeah, let's merge maybe 3 and 4.
4 is long though.
Oh, it's not.
But it will be approximately even.
4 goes over 2 full columns.
You need to get then if you
No. You know.
So are we gonna do the number postulate that corresponds to our name?
yes.
Okay.
Well, 3 itself is too short.
3.5 of 4.
Or you gotta commit to the whole.
How can you explain half of the concept?
and 3.5 of 4 and 3 pizzas.
What you're saying is once you put it up between you and Elsa already got 5.
Let's just whoever
You know
does 4 gets double credit.
I'll do 4.
But I recommend Eva does it. Just it will be logical one after another. Or you can swap with Sam.
No,
You do 2 and he does 3 and 4.
I think I'll pass. I wish you the best.
And I'll help. Thank you. So 3, 4, 5, 6. Oh, this 6 will be too easy. We need to give too easy.
Give it to Ava.
No, that's why we can share 4.
No, just give him 4 and 6.
You can swap if you want.
Oh. Guys.
Yeah, but 4 is many.
4 is.
As long as
But yours is a sentence, mine has a whole equation, but it's okay, a paragraph, mine has an integral.
Not that bad.
I'll try to mention it. Yes. Yep.
Okay, Ava, do you want to switch and I'll do 3 and 4? No.
Aha.
Complain about it so much.
I am cleaner.
Yeah, I know.
I think we all kind of are.
So we are in the physical chemistry course, but in some sense we are in. We can rename the course and call it Nobel Prizes in Physics. Because what we use it's Nobel Prizes in Physics at the beginning of 20th century, and then basically each phase or each prize will be like a couple of lectures. You're okay because everyone is okay.
I'm just looking at all these names and I'm just like, dang.
And is this related to the postulates or is this a separate?
This is pretty fun.
It's all related. It's all. I'm not teaching postulates. Not speaking it up because you saw it. It's just
Google.
to
So we we just have to like explain it to the class.
Right.
Is it really to a class?
Yes. Yes. About PowerPoint, yes. Send PowerPoint by midnight before you present. And then,
We're supposed to create a PowerPoint.
oh, sure. And then I'll
Thursday night?
yes. And then I upload all of them here because with 5 people, one can come with memory stick and waste time on loading and unloading. It's easier than previous years when it was like dozen people, but it's better if you send, I put them all organized, and then you just come, speak, return.
Hello.
Okay, so what did this guys did? I have no idea why I'm showing this slide.
Always
That's fair.
something.
When yes, history notes. When students evaluate faculty, and now I know that Eva will give me negative evaluation for giving too much unfair tasks. But from time to time, faculty evaluate faculty, and sometimes they are a little bit more critical than expected. And I've got critical notes for being unable to write on the blackboard in a way that people understand. But the only positive note that was about history notes. So when other faculty were evaluating me, they liked it. Okay, if it is good, I can show. But we can go through the material without it. So Prince Louis de Broglie was doing basically the same things as we discussed on previous meetings. Well, he was not sitting on the pool party and putting waves. He had enough waves because he was playing trombone and was thinking about waves, and he thought that yes, waves are related to electrons somehow. So he was not doing much math, but like pushing this idea, and just because of giving this idea and protecting it, he was awarded. Raman provided experimental evidences that teach us that nuclear motion of ions needs to be quantized. And you see, the order of the awards is not the order things were discovered. So I would reorder them and put him much later because other things are more important. Dirac is responsible for Bryant-Kent notations that we did last time in the lab, right? Schrödinger is like we can, if you narrow down the PKM1, we can call it notes and Schrödinger equation. So it's foundation of everything we do. And Heisenberg was a competitor of Schrödinger, so he was able to provide a theory that describes these same processes for these same atoms and molecules, but his theory is a little less user-friendly. It's like stick shift against automatic, and we need to include him in all our considerations, but his theory is less popular, and it's a little more abstract. But to have the overall idea, we will return to his theory. And once, well, not once, they were meeting, not only these guys, but few other people were coming together, discussing what they discovered and coming to the common vision of the problematics. And when they were making these meetings and signing the protocols of the scientific meetings, it is how the postulates were developed. So it was a like creed of quantum physics. So it was a long clashes because before they agreed on interpretation and formulation. Why postulates are needed and why I'm trying to avoid them? It is less mathematical. You see, you were unhappy for equations, but I'm unhappy for too few equations. So it's much more setting up things that are foundation for the rest of the class, and many of them are not possible to prove. It is a matter of accepting, believing, seeing that they are natural, and one can start building mathematical models and predict behavior of natural objects based on these ideas, but they are not derivable. Okay. I'm not going to read it. I'm not going to invite you to read it right now. If you want to look at the notes later, we can do it. But why I'm showing what are these many lines of text and what is the reason to show them? So after becoming famous and giving lectures and being accepted as one of the fathers of quantum theory, people were asking Erwin Schrödinger to publish papers, write lecture notes, and teach others. Like, we all use your equation. How do you come to this equation? Where it comes from? And there are no formal papers, or people are trying to escape, because by scientific mindset, this philosophical discussions are not favorite things. They need it, but it is like thin ice. Instead of doing derivable equations, you may say wrong words and you will be, or right words. So it's very, very imprecise. It's too much to like linguistics and humanities. And practicing scientists try to avoid it, but if their arms are twisted, they squeeze few words out of themselves. So Schrödinger gave his train of thought, the way how he derived the equation, not in the actual papers, but when he combined them into like booklet where several papers are combined, he wrote a preface. And there he went against his standard practice and gave just ideas that he believed in while deriving an equation. And one of the well, there were several ideas. So after he was trying to combine things that we were already discussing, and there will be nothing new, it will be different verbalization. One, that electrons, if they do not see atoms and ions, are able to propagate freely like rays of light. Another, that they demonstrate some wave behavior, and if there is a wave behavior, there should be wave equation, and how to combine straight propagation and wave behavior. And by the time he was practicing, some mathematical foundations for this class of problems were already designed, because for music, for like strings on guitar was a famous problem for math, and it was solved or almost solved at the time of Napoleon Wars, so like more than 200 years ago. And quantum mechanics is about 100 years ago. So basically, people needed to make a philosophical effort to forward mathematical tools, just 100 years forward, backwards, and apply them. So you see here, he uses the constant that Sam knows by 10 digits. There is a variational principle. So it is a concept that is you also touched. We discussed together when you got credit for 400 level physics class, least action principle, right? So least action. Do less, get more, right? So way how one can get a trajectory corresponding to least action is to design arbitrary trajectory, vary it, disturb it a little bit, like to the left, to the right, and look whether it will increase or decrease action. And this approach of solving problems to change a parameter and see if it improves, gets better or worse for aim function is often referred to as a variational principle. So he was just thinking about all these concepts together and finally came up with equation. I don't know if you need it, but some of us could be curious, like how does one derive Schrodinger equation? One does not derive it. It just was an insight. Okay. And another thing that we will touch together, that Schrodinger equation that we will pseudo derive. We will not derive, but we will show the way where it came from, can be chopped, can be, if we speak on the language of differential equations, we can practice so-called separation of variables. And then one can separate solutions that are responsible for behavior in time domain and in space domain. It's not always possible, but for a lot of basic problems, it works. And the removal or the time domain from focus and looking only on space domain will generate problems that mathematically are characterized as eigenvalue problem. Please support if you are happy with the word eigenvalue problem, or you hate it, or you heard something but you don't remember what it is. Do not hesitate, or you can, so that if you hesitate, your classmates or eigenvalue.
The name familiar, but I would not be able to match the description to the name. Eigenvalue.
I know I did eigenvalues and eigenvectors last semester in linear algebra.
Yeah.
Yes.
But I don't remember.
Okay. So here is our teacher for next section.
I just said I don't.
Quantum theory didn't design new mathematical tools. It was just smartly absorbing and utilizing what humankind already knew. And it was just out-of-box thinking, because it differs by way one approaches problems very much compared to what people were doing before it. So at least I will show this eigenvalue equation before, and it is practiced in linear algebra, right? But there is eigenvalue problem in differential equations. And as we started to believe after Paul Dirac, who designed this Brian cat, there are similarities between like vectors and functions, matrices and operators. And we haven't defined what operator is, but I will repeat it again and again. So in these two domains, linear algebra and like differential equations, there are a lot of similarities. And eigenvalue problem can be practiced both in matrix representation or in differential operator representation. So I'm giving these notes before we go to equation, because it is organized in Schrodinger book this way. The eigenvalue is an attempt to translate to English his original terminology. So he was a citizen of Austria with native language German, and eigen means proper, appropriate, own, like something that I own. And if one wants to be more precise in English, instead of borrowing German word, one should tell proper value or own values of an operator or a matrix. Okay. So it is what we did last time, and we didn't go to the equation, but we got to the equation for predicting future, right? So if you have wave function of the past, initial, we can get wave function of the future by applying to it the evolution operator, which includes this imaginary exponential and phase corresponding to action, which grows, accumulates as particle goes along the trajectory. Okay, so yellow thing is evolution operator, H is Hamiltonian operator, and we will use word operator more often and more rigorously. Now, in the okay, generous 20 minutes. As far as I remember my own slides, we need to do at least two things. So one thing is to jump from evolution operator to Schrödinger equation, which does have time. So it's time dependent Schrödinger equation. And second thing is to move from time dependent to time independent. So we need to cast a spell to remove all time dependence from here, but in a rigorous mathematical way. And then we will arrive to eigenvalue problem that Schrödinger was defending in the preface to his collection of papers. So here is the stuff that we were, well, I was drawing and we were agreeing by not protesting. And evolution operator. Okay. For the sake of time, I would show some very ugly handwriting recorded on a screen. I would very much prefer to scratch them on the board, but maybe we save a little bit time. If I see that you lose attention, lose contact, start falling asleep, then I will give up pace and we'll go more to interactive mode. But as long as you like alert and following, maybe I'll try to show some of them. So how do you call when you take derivative of product? There are like calculus rules. Product rule, right? So now on the top line, we do have our prediction of the future. And we do on the right side, we do have evolution operator and wave function. Both of them formally have dependence on time, right? So we may want to do a mathematical experiment to see how this evolution, not evolution operator, the equation that predicts future changes over time, to look for small increments. So let's practice time derivative of left and right part. So left part will be just time derivative and right part will be product rule. So first term is a derivative of evolution operator times wave function unchanged. Second part is evolution operator times derivative of the wave function, right? And if someone gave us the initial wave function, it is a given thing. It doesn't change over time. Then we can assume that its time derivative equals 0. And then instead of two terms, we have only one, right? So time derivative of evolution operator times unchanged initial wave function. Now, we do need to take derivative of the imaginary exponential with Hamiltonian, integral of Hamiltonian in the power. How do we do it? Well, derivative of exponential is exponential, right? And then you need to teach me another terminology, chain rule, and then times derivative of the power, right, of the inside function. So if we take derivative of integral of a function, I bet we will get the function itself, right? And the factors stay here. So it will be minus I h bar, Hamiltonian operator, which is like total energy, kinetic minus potential, times evolution operator. You believe me? You do not oppose this little derivation, and we can go forward based on it. So this and on the right side we will still have this wave function, right? I don't remember what will be on the next slide, but let's look on it constructively. So time derivative of the wave function will be evolution operator times wave function, which will be wave function itself. But upfront, it is multiplied by factors and Hamiltonian operator. Yes? Everyone agrees? If you disagree, let me know. I will try to defend this statement. So we can, this factor stays up front. This is U, evolution operator, and we also have the wave function, initial wave function. But evolution operator times initial wave function will be wave function in the future. So if we combine these things, we will see that time derivative of the wave function of the future will be equal to the wave function of the future, but multiplied by Hamiltonian operator. Anyone wants to oppose? I will not take it against me. Anyone wants to oppose Schrödinger?
Nope, I'm good.
So if I quickly run back to the beginning of the slides, yes. So, and it should be same symbol, psi here. So wave time derivative of the wave function of the future equals to wave function of the future multiplied by factors and Hamiltonian operator. You believe it now? So this is an equation for which Schrödinger got his Nobel Prize. You see, at the beginning of 20th century, it was not so complicated to get this prize. Yeah. Okay, let's keep going. We should use time machine, get like a year before Schrödinger and just publish.
How much time did it take?
Okay.
History and future.
And I think here I was just trying to improve my writing skills and replace it by typing, but it's basically the same, right? Derivative and time-dependent Schrödinger equation. Now, we even have generous 13 minutes. Before so my goal is to perform separation of variables, to get dependence on space and dependence on time separately. But before going there, let me do the same thing as we practiced together in the lab. We recalled the definition of the derivative, right?
Yes.
So the time derivative can be expressed in finite differences. Yes. Like future minus near minus present divided by time increment. And here I was just calling someone from previous year class to write it, and therefore here is the present minus future, and then we put the minus sign here. Okay, now let's multiply left and right part by delta t. Then near future minus present equals Hamiltonian operator present delta t. Yes? And we can migrate this present to the right. And then we see near future equals present minus wave minus Hamiltonian operator times present times delta t. So this approach could be a little more practical for numerical computations. So as far as we know the present, we can propagate forward toward the near future. So in the same way as we do with evolution operator. So the goal of time-dependent Schrödinger equation and evolution operator is to predict future. Okay, accepting, not objecting. I know that if I would do it a little slower, deriving on Blackboard, if you would take notes, it would solidify a little bit better in the memory. But we all are adults, and I'm not going to play this game like. Although one day we can like play cards. So second way to predict future from past to the future, and here is 1 minus this Hamiltonian times delta t, right? What is this equation? I'm just trying to save time and not to so exponential to the power x equals 1. Can we believe it? Only if x equals 0, right? But if x is slightly different from 0, then it is 1 plus x. If it is a little more away from 0, then it's x plus x squared over 2. Do you have good memories about this equation? You never saw it.
Oh.
So was it like calc? Okay. So it's Taylor expansion of any analytical function. Okay, and now look here. So it looks like exponential of e to the power minus I h bar h delta t, right? So it's like Taylor expansion of the evolution operator. So we started from evolution operator, derived Schrödinger equation, and now arrived back to it. It is not a proof. It just shows internal logical consistency, right? Commutation. We will practice this concept again and again. It is not as important for Schrödinger, but it is a critical concept for Heisenberg approach to quantum theory. Commutation means swapping the order. And we do have rules of multiplying matrices. So matrix multiplies vector from left to the right. Typically, if it is a column vector, then square matrix acts from left to the right. If you do have differential operators, typically normal people, not crazy people, just do differential operator on the left and function on the right. So order matters, just in linear algebra and differential equations. Quantum theory uses it. So like it's not like 2 times 1, 1 times 2 is the same. If we do derivative times wave function or function times derivative, those are not equal. You agree?
Oh. No,
You disagree or you agree?
I disagree.
Because this differential operator acts from left to the right. So now it acts on this function and maybe anything there. Now it acts on nothing. So this swapping of the order matters. And a lot of quantum theory is just playing these games of swapping orders or observing how mathematical properties differ of the swapping order. And the simplest example to get through this concept is to look on this little example. So derivative of x times function. So the derivative of x times function will be derivative of x times function plus x times derivative of function. And we can look on it. Derivative of x will be 1, right? And here is 1 times function plus x times derivative of function on one side, and on another, it is derivative of x times function. So if you want to migrate this x times derivative to the left, we will see derivative of x times functions minus x times derivative of function equals function. Yes, or you want more on this? Yes, no, or it is too quick, too silly? Just please confirm if you are okay, or you want me to speak a little more.
That makes sense.
So this is looks like kindergarten calculus, but looking on this line and recognizing what is shown here prevents from a lot of confusion in the rest of semester. So it's not a little exercise right now. It is like opens a door to much more advanced things. And if we symbolically remove wave function by this yellow stuff removed, then we will have derivative times x minus x times derivative equals 1, because it is like identity operator. So swapping derivative and function x is not innocent. If you want to swap them, we pay price, which is 1. And in a lot of derivations, one assumes function, but one doesn't write it down. And here one would say commutation of derivative and position operator equals 1. Okay. Later on, one would derive important consequences. So it's just the simplest example we can look at. Okay. Yes. So one can put just empty spot. Operators. Anything. Now I need to speed up to finish in 3 minutes. Things that people observe on experiment are observables. Or like when we did high school or middle school physics, there are like variables that describe our models, like position, momentum, velocity, angular momentum. And anything more complicated is composed of them. So in classical mechanics, one just use them as variables and pose differential operators for their values. They start depending on time for trajectories. And in quantum theory, one replaces them by a differential operator. And right now, it should look crazy to you. But the goal of the course that it will not look crazy to you at the end of the course. So the operator of momentum is replaced by derivative over position. I hated it when I saw it for the first time, and it took me years to accept. And one of the postulates can be illustrated just by demonstration of this table. And No, I wanted to show more.
I guess
Really?
if it's the end.
Okay, it is then. I was rushing to do the eigen values, but probably it would be reasonable to postpone it to Wednesday. Okay. So you have 2 minutes for questions if you have some. Questions, complaints, suggestions.
Fun plans for the semester or the long weekend?
Teach no classes. We
All 5 should be done on Friday.
Oh yes. Presentation plus questions no longer than 10 minutes because we have 50 minutes, right? So if you
Question section.
Oh yes, you all are encouraged to question each other, and if no one asks questions, I'll start asking questions. And if the presentation goes too short, there will be more questions. But no longer than 10 minutes, so that we do not step on our own tail and do not screw our rest of the schedule. So next Friday.
What are you gonna be evaluating?
Or critical thinking skills?
Like, what if our presentation is really solid and then someone asks a question and you like can't answer it? 0 points.
I really let's stop recording because record. Okay, I will provide. That's a good approach. Yes. Okay, and I know I was undergraduate student myself, and it looks like different sides of the barrier, but this subject is so complicated. I do not want the subject be between us. We together as colleagues should try to go over this barrier. So it's right. The subject is abstract concept, and we all are humans. So we have much more in common between us than like myself with a subject.
Education is a competition.
I will keep doing,
Not enough for me to speak to other.
I can't believe you got